code is the visualization for the algorithms. So like you saw in the previews and the examples, each of the columns were at a random height and they represented a random number inside a so-called array, which we're going to program afterwards. So this program will be in HTML, mostly in JavaScript, but we're going to incorporate the JavaScript inside the HTML file. And yeah, I'm writing in Sublime Text over here, as you can see, and this is Google Chrome over here. And make sure every time when you code, you save it. The shortcut for Mac is just Command S. For Windows, it's Control S, and then you refresh this page. Okay, so yeah, let's get started. So the first thing you want to type in is HTML, so you can get this set up. And in the title, you don't really have to specify this, but just for fun, you can just type in selection sort, because the first algorithm that we're going to program is the selection sort algorithm. Then in the body tag, you can source the p5.js library, because this will help us make the canvas and the rectangles, the columns, etc. So make sure that the p5.js library is in the same directory as this HTML file. If it's in a folder which is in the same directory as your HTML file, then you have to like type in the name of the folder. Let's say the name of your folder is JS, and then slash p5.js. But in this case, p5.js is in the same library as this HTML file. Then type in another script tag, and this is where we're gonna program all of our visualizations and our algorithms. So the very first thing that you want to type in is function setup, because all p5.js programs have a setup function, so it's like a setup function, right? It's in the word. So you want to create a canvas first by calling this function create canvas, and then you have to specify the width and the height. So first the width and then the height. So in this case, we can give the width to be 800 pixels and the height to be 500 pixels. Then right above, let's create an array called random array, which is going to be where we keep all of our random numbers, okay? And then later we can draw rectangles and columns out of them. And we can also have another array, and another variable, and I guess you can call this const instead of variable, but whatever. So variable number of columns. Again, this will be like basically how many elements there are going to be in the random array. And let's say we want 500, okay? So it's going to sort 500 random numbers. So in the setup function, you want to basically create those random numbers. So let's start off by doing var I equals 1, because the very first number is 1. If you want, your range can be from like 100 to 1000 or 100 to 600 in this case, whatever you want. But I'm just going to go from 1 to 500. Then I'm going to say I should be smaller or equal to the number of columns. So this will, and then I++, this will basically iterate through each number from 1 to 500. Then we can do random array dot push. So we're appending I at the end of random arrays, okay? But this isn't really random, right? It's just going to be 1, 2, 3, 4, 5, 6, 7, and so on, in order all the way up to number of columns. So now we have to randomize this array. So let's just say for I is, and we can use I again because it's not going to interfere with this loop, is going to be equal to random array.length -1. And let's just go backwards now, just to make it more fun. So here we went ascending order, like from the start of the array to the end. Here we're going from the end of the array to the start. Doesn't really matter, but yeah. So then I should be bigger than 0, and then I minus. Okay. And I++ means you're increasing I by 1. I minus means you're decreasing I by 1. So then we can have a constant j, which is equal to math.floor of math.random times random array.length. So what will this do? This will basically get a random index. So this j is like an index. It will get a random index from the random array, and yeah, that is going to set that to j. So Then we can use this ECMAScript notation and do random array of the I, random array j, and then we can swap them around. So we can say random array j and random array I. Okay, so basically random array I is going to become random array j, and random array j is going to become random array I. Okay, and yeah, there we have it. We just randomized the array. But now let's create the canvas. Okay, so right now we won't be able to see anything. If I just Control S, Control R, yeah, there's nothing on the web page. But in the console, if I type in random array, then you can see it did randomize the array. If I do that again, it's continuously randomizing the array. Okay, so let's create another function called function draw, and this outside of the setup function. Let's say, sorry, background 0. Okay, so now we're going to be able to see a canvas, which is 800 times 500, and with a background of black. Okay, so now we have to draw each of those columns. Okay, which are like corresponding to the random array, each of those elements. So first go through all of the elements in the random array, length, and then I++. And then to create a rectangle in p5.js, you have to call the rect function. And this has 4 arguments: x, y, width, and height. Okay, height. And for the x position, that's quite easy. That would just be the width of the canvas, which is 800, divided by the number of columns, and then I times that. Okay, and that's just basic math. Hopefully you understand that. And similarly for the y position, that would be 500 divided by the number of columns, and then instead of I, we're going to do random array of the I times that. Okay, times that. And then for the width, we're just going to take this value, put it here, and then we're going to take this value. No, this value. No, this value. Sorry. No, yeah. For the height, that's just random array of the I divided by. Yeah. Okay, makes sense. So it's just going to be this over here. So yeah, you can see that's a bit weird how it looks and everything, but that's because we want all these columns to start from the bottom over here. But in p5.js, the x and y axes start from here. So x increases like that, and y increases downwards like that. Okay, so we have to say 500 minus this for the y position. Okay, and yeah, there you go. Now you have a randomized array of columns, you could say, and then we like mapped it so it fits in within the range of the canvas. Okay, and yeah, that's basically the template for creating the visualization of each of the algorithms. Okay, and now we can just basically write the algorithm separately, and it will organize all of these columns from ascending order. Okay, the selection sort algorithm. Okay, so basically what this algorithm does is it finds the minimum value of the unsorted array and puts that at the front of the unsorted array. Okay, so like you saw if you look at the visualization for the selection sort algorithm, you can clearly see that from the end, like for the second part, which is the unsorted array, it's continuously just finding the minimum value and putting it at the very front of the unsorted array. Okay, so let's just go ahead and program that. So first we need a global variable, so outside of the draw function, which is equal to 0. And one thing to notice is that the draw function is actually like a for loop, so we don't need to write a for loop which iterates index, okay, so which increases index. So think of this whole thing like a for loop, which is var index is 0, index should be smaller than random array length, and then index plus plus. Okay, it's pretty much the same thing, but the iteration is slower, so we will be able to see the rectangles actually going like that. Because if we do it with a for loop, it's just gonna give us that sorted array. We won't really be able to see like the animation. So obviously in a real life scenario you would use a for loop and not a draw function like in this case, but yeah, anyways, let's get started. So the very first thing you want to do is say yes. So var min is infinity. Okay, and the reason why we're doing this is so we can calculate the minimum value. Okay, so obviously the initial minimum value must be infinity, and then we need to keep track of which index has the minimum value. So just say index of min, and then create a for loop which goes through all elements of the random array starting from the unsorted array. Okay, so we'll say var I is equal to index, not 0 but index, and then I should be smaller than random array.length and I plus plus. Then we say if the random array of the I is smaller than the minimum value, then we have to update that minimum value. Okay, so we have to say that the minimum value is now equal to the random array of the I, and this is because we found a new minimum value. Okay, and then we also have to update the index of min variable, so we can keep track of which element is the minimum value. So now, if you go outside of the for loop, then we can use this ECMAScript notation over here. So just copy that and paste it over here, and we basically have to update the minimum value. Okay, so and we have to like swap some stuff around. So we have to say random array of the index and random array of the index of min, they are to be swapped around. So you have to say index of min and index over here, and this is because the current index, that's going to be swapped with the minimum value, right? Because we're going to put the minimum value at the very front, so the index is going to have to like go away, right? So yeah, hopefully that makes sense. And this actually makes sense if you sort of compare this code with the preview. You can see that in the second part, in the unsorted array, what the algorithm is essentially doing is it's getting the minimum value and putting it at the start of the unsorted part each time continuously. So yeah, that's what this does, and then we basically have to increase index, so it just goes through the random array. And then at some point we have to stop the program, or like stop this iteration. So we can just say, we can wrap all this around an if statement, which says that if index is smaller than the random array.length, then do this. Okay, so as long as we're within the bounds of the random array, how many elements it has. But the moment it overshoots that bound, then there's like this p5.just function, which essentially stops this draw function, because this draw function is like a loop. It's like a continuous loop. It basically breaks out of that. And yeah, let's see if this works. So make sure you save this and then refresh. Yeah, so what you can see is it's basically finding the minimum value over here and putting it at the front. Okay, and that's why all of these values are larger than this value over here. So if I just refresh that, you can see that all of these values are larger than this value over here. Okay, all of them are, which is pretty cool. So that's the selection sort algorithm. Now let's get to the insertion sort algorithm, which is really cool. Sort algorithm. The very first thing you want to do is just get the selection sort algorithm, paste it over here, and delete everything that has no association with the algorithm. Sorry, that has association with the algorithm. So if you just save this and refresh now, you should get the the visualization, the very basic of the visualization. So no algorithm stuff, nothing like that. Okay, so this code over here basically just draws all of these columns. But now we're here to draw this algorithm, to program it. So let's go ahead and do that. So this program also requires an index variable that is global. So make that outside of the draw function, just like in the selection sort algorithm. And you can also name this insertion over here. Insertion sort. Yeah. So first of all, we need a variable index. Okay, and I'll explain why just in a second. And also with this for loop, I'm also going to explain why this for loop is like it is. So the insertion sort algorithm, what it does essentially is it has a sorted part and an unsorted part, like you saw in the visualization. And basically the sorted part is over there, and what the algorithm does is it goes through each of the elements, each of the rows, sorry, the columns in the unsorted part, so in the latter half, and it puts it accordingly in the sorted half. So let's say this half over here is sorted. Okay, so instead of these random lines, it's completely sorted. So it looks like a triangle. And this half is completely unsorted. And what it does is it takes the first element of the unsorted part and it puts it accordingly in the sorted part. Okay, so where should I put that? Let's say it's this height over here, and let's say there's like the sorted array is like this, and this unsorted element over here is over here. We basically have to keep going until, yeah, right over there. That's where it belongs. Okay, and how does it do that? It keeps going until it keeps going through the sorted part of the array, and it does that until it finds something which is smaller than itself. Okay, so we just say if the random array of the of the variable index is smaller than the random array of the I. Okay, because this loop over here, it's going through the sorted array. Okay, it starts from the index, the variable index, and it starts from that -1 because at the variable index, that's like the index which you are on right now. That's the first element. So variable index, that's the first element of the unsorted array. And the reason why you want to do -1 is because you want to start with the one before, which is the last element of the sorted array. And you're basically just going through all of the elements of the sorted array, and you're saying until the random array of the variable index, which is the first element of the unsorted array, is smaller than the current sorted array element. Okay, it's a bit confusing, but I think if you look at the visualization, then you'll understand it better. So then we use this ECMAScript notation again inside this if statement, and we say random array I and variable index, we basically want to swap them. So variable index and I. Okay, so so basically what this does is it like let's say we're over here. Okay, so this is a sorted part and this is the unsorted part. We're over here right now. That's the index I, and we said that the first element, let's say that's the first element of the unsorted array, it belongs over there. So you want to swap them. Okay, you want to not swap them, but like you want to insert it into there. Okay, and then what you want to do is you want to decrease the variable index. Okay, and why do you want to decrease it? Because it just changed, right? The variable index just changed because you just swapped the variable index. So now you want to decrease it by -1 because that makes sense, right? So afterwards, at the very end, you also have to, so if, so this outside of this for loop, if the index is equal to the random array dot length -1, then the index is going to be equal to 0. So in this insertion algorithm, it doesn't just go through the whole array once. It just keeps going, right? So index ++. Yeah. So this basically stops the array at some point. So yes, I think that works. So if we just save that and refresh, you can see that it basically finds like this element over here. That's the first element of the unsorted part, and it basically puts it accordingly in this sorted part. That's basically what the insertion algorithm does. So once again, let's say we're taking a look at this. That's the first element right now, and it basically put that somewhere over there. Okay, that's the insertion algorithm. And there are many ways of doing this, but I think this is like a really simple way. So yeah, that's the insertion algorithm. So the last algorithm is the bubble sort algorithm. Once again, to program this, copy the code for one of the other two algorithms and omit everything that has nothing to do with the graphic visualization itself. So this, and that. So yeah, so now you must have a canvas 500 times 800 with random heighted columns. So what is the bubble sort algorithm? It's basically an algorithm which sorts something, but it's the most inefficient way, I would say, because suppose you have an array called x, which is 0, 53, 12, 7, and 8, or say 10. Then what it does, it starts off with the first element. Okay, so let's say it's 0. It is 0 in this case, and it checks if 0 is smaller than the element next to it, which is 53. And if it is smaller, then it's going to leave it like it, but if it's larger, then it's going to swap the two. So in this case, 0 is smaller than 53, so it's just going to leave it like that, okay? So now we have the same thing, like that. And now it goes to 53, okay? So is 53 smaller than 12? Yes, sorry, no it's not. So it will swap 12 and 53, like that. And then 7 and 10. Then it goes to 53 over here, because now they've swapped, right? So it goes to 53 again. So it basically goes through each index. First, second, third, or like 0, 1, 2, 3, 4. Okay? And 0, 12. Is 53 smaller than 7? Nope. So it's going to swap it. So 7, 53. And then 10. And then it just basically keeps doing the same thing, and eventually you will get a sorted array in terms of ascending order. So I would say this is also probably the easiest to code. It's really easy. All you have to say is var index is 0. So notice how all of these have an index equals 0 public variable or global variable. And what we have to do is say that if index is smaller than the random array.length minus 1, and the reason for us doing this is because we don't want the very last element, because at some point we're going to do index plus 1. Okay, so suppose we have an array x equals 1, 2, 3, and let's say we're on the last index, which is index 2. Then if we do index 2 plus 1, then that means index 3, right? But there's nothing after 3, so that will raise an error. So we have to make sure that we don't consider the very last element. And now we have to use some more ECMAScript notation. So we have to say, I'm just going to copy this actually. So here, random array index, random array index plus 1. Okay, and we're going to say that if the random array index, so the ECMAScript notation that I'm about to use, it's like a conditional statement, which says that if a condition is true, then do this or do this. Okay, and if it's true, then do this. If it's false, then do this. So for example, if 3 is smaller than 7, it's going to do this. But sorry, smaller than 7. But if let's say if 8 is smaller than 7, that's not true, so it's going to do this. So this is the true part, and that's the false. This is the false part. So we're pretty much going to do exactly the same. So random array index, if that is smaller than random array index plus 1, question mark. If that's true, then you're just going to leave it like it is, okay? Because, you know, that's the proper arrangement. But then you put a colon. But if it's not true, then you want to put, then you want to swap them around. So you want to put index plus 1 and index. And done. That's pretty much all you have to do. But the bubble sorting algorithm, it also, at the very end, it checks if each, like, it pretty much does this over and over again until everything, like at some point you have to check if everything is correctly sorted out. So let's go ahead and do that. To do this, let's say if, so if the index is equal to the random array dot length and then minus 1. So this basically if we're at the last element of the array, then you want to reset the index. So you just want to keep doing it over and over again. And now you have to compute the number of errors. Okay, so like how many errors are there? And what I mean by errors, how many like misplacements are there? Okay. The way we calculate the errors, we have to loop through all of the elements of the array, so random array.length, I++, and then if, first of all, if I is not equal to the random array.length -1, so I guess you can just say I should be smaller than that -1, so we don't need this if statement in that case. Then you can say if random array of the I is larger than random array of the I+1, so that's an error because that shouldn't be the case. We want ascending order, so I should be smaller than I+1. Like the random array I should be smaller than random array I+1. So if that's not the case, then errors ++. And what is errors? We have to create a variable called errors, which is 0. Okay, and errors ++, and then break. Okay, because if we have one error, then that means we still have to continue fixing and sorting out the system. So we're going to say if errors is not, sorry, if it's 0, then that means that we have successfully sorted out the algorithm. That means there are no errors, so no loop. That basically means that you stop the program in a way, not really. And then you basically, in the second if statement, so in the external one, you have to put else index ++. Okay? So basically, if we're not at the very last index, then increase the index, obviously, because then how else would you increase the index? So yeah, that's the bubble sorting algorithm. Let's check if this works. Sorry, no. Is this bubble? Yeah, it is. So let me start with bubble sort. And I'm just going to make this around 20, or let's make it 10, okay? Because the bubble sorting algorithm is really slow and it's really inefficient, okay? So save and refresh. Yeah, there you go. If you want, you can make it like, let's say 25. So notice how it goes through, like it's sort of going through each of them and then it's sorting them. But yeah, that's a bubble sorting algorithm. And with the insertion sorting algorithm, a lot faster. You can see here it's doing 500, if I remember. And this, I think, either the insertion or the selection, one of them is like 0.3 seconds shorter or like quicker than the other one. If we do 500, obviously. And then this is the selection sorting. So it's completely different to the insertion one, because this one, everything here is larger than the sorted, the maximum value of the sorted. So yeah, so that was the end of this video. If you liked it, make sure to subscribe, like, and comment for new video suggestions and feedback, and I'll see you guys in the next video.